So in order to illustrate how to apply this Johson-Cook model, I created this simulation that's so simple. Is a two-dimensional simulation with two, rigidity 2, and a workpiece that is going to be cut. Okay, let's first start with the property definition. Of course, I go here and I create a section for our analysis. So it's going for, of course, for a two-dimensional analysis. It's not so not so intuitive, but you have to put solid section in a two-dimensional. It is go to further discussion. Okay, still Johson-Cook, and right here. So material is still JC that we have defined. The plane stress, strain, thickness 1v1, the default, just for this example is okay. Yeah. Okay. So go here. I'm gonna assign this section to the workpiece. Okay. Now the section for the workpiece is defined. I'm going to ascend. I just jump at the stack that is so simple to organize the items in the model. Second, we're gonna go to step. We're gonna create. I'm gonna create a dynamic step. So they're gonna name as cutting. So dynamic explicit. For time, 1 second is okay. I'm gonna use mass scale in the model, but just for run analysis faster. Of course, if you want to measure the forces, you have to be really careful with mass scale because it's gonna influence, it's gonna affect the results really in a big way. But for our case, it's okay to use mass scale. Now comes an important thing. In our field output requests, you're gonna edit and you're gonna ask for the state and the status failure for the material. Okay. Second, for the interaction, we cannot forget to define a reference point for the rigid part, that is the 2, of course. We must do it because as the 2 is a rigid body, you apply the boundary conditions in a point because Abaqus don't see the body itself. You see a point, and all the inertia and physical properties are going to be calculated in this reference point for the rigid body. So we're going to rigid body. Okay. Don't select so point right here. Okay. In our case, as just example, in the contact properties, we just want to account for a normal behavior, just for simplification. Okay, dismiss. And for the interaction between the bodies, you're gonna create, in my case, is always work better. I'm gonna create a surface to surface contact. So selections. I'm gonna name it this interaction. So let's select the first surface. Sorry, right here, and right here. Okay. Now, of course, we have to flip the surface so Abaqus can consider the normals in the right direction. Okay, let's flip it. We're going to select magenta. For the second surface, we're gonna select node region. Okay. You're gonna click on the workpiece. For mechanical constraint formulation, we're gonna choose the penalty contact method, and of course the contact property. We choose the contact property that we defined beforehand. Okay, so far we defined the contact definition. Second, let's apply the boundary conditions. We're gonna fix the workpiece base. Okay, and we're gonna apply a velocity in the tool. We choose the reference point, and what is important, you have to put 0 in other degrees of freedom in order to the analysis not in order to analysis not fail. Okay. Okay. So far so good. Okay, so now let's define the mesh. So select the part for the piece, and as a global seed, I'm gonna put 1.5 because in the fractal calculation energy, we calculated the criteria with 1.5. But of course, if you have a mesh that varies in the volume or in the area, we have to discuss further how to apply an analogous approach. But for our case, we're gonna select 1.5. Okay, apply. So we're gonna mesh the part. For the two, just the default mesh is okay. Now, an important thing that I forgot. In the workpiece, you have to select the explicitly, sorry, to have an element deletion to Abaqus select the element. So I'm going to put explicit and for element deletion, we're going to put yes. Okay. So I think I have choose everything. Okay, now I'm gonna create a job. Okay, I'm gonna name it as cutting. Just click OK. Now I'm gonna submit. Okay, really a fast analysis, just a couple of minutes. It's gonna be completed. Okay, let's now check the results. And as you can see, some of those elements couldn't check for the failure criteria, and this happens because the mesh is really coarse. But if you want better looking results, you can of course refine the mesh. And if we go back in the property and okay, edit damage evolution, and if we put 0 here, let's see what's gonna happen. Okay, let's pause a little bit. So in a couple of minutes, the analysis is gonna be completed. So let's check the results. Okay, as you can see here, you have pretty much better looking results, but of course, the analysis is not right in some way because if you put 0 as the energy criteria for failure, you're gonna compute the forces for the cutting process. The forces is gonna be so much so much far from the reality. Okay, so uh, you of course, if you want better results, instead of put 0 as energy criteria, you have to refine pretty much your mesh. So because when you refine your mesh, you're gonna concentrate stress in this point, and the element is gonna be deleted. So, but here we have the results. That is pretty nice.